Presents Homework Hotline, the after-school show that fuses learning with fun. Watch local teachers bring the classroom on air and online. This is Homework Hotline.
Hi, I'm Beth Baker and I teach math at McKinleyville Middle School in McKinleyville.
And I'm Jody Himango. I teach 7th grade science at McKinleyville Middle School.
So, welcome to math and science time here, and we are going to today talk about some number tricks, and then we're going to talk about the algebra that makes them happen. And then if we have time, we are going to make a birthday card where you can make a birthday card that always comes out to the birthday person's age number. Maybe this is better for kids than adults, I'm not sure. Because maybe if you're turning 67, you don't need a birthday card that always comes out to 67. But anyway, so we're gonna make a birthday card today that has a number trick in it that comes out to a person's age. So it's a pretty cool trick. Today's a great day for calculators. So if you happen to have your phone handy or this beauty right
Vintage.
here. Oh, vintage, yeah. I think we're seeing those on Antiques Roadshow these days. So, yeah. So in any case, whatever you have, and then of course paper and pencil is fine, but we're hoping you get ambitious and pick crazy numbers like negative 22.4 just to see that our number tricks always work no matter what you pick. Here we go. Do you have a quick little comment about weather or what's going on in the world scientifically right now? Anything, any breaking news that you want to share with the group?
None that I can think of, other than I hope everybody who is 18 or over votes today.
Oh yeah, today's voting day, so that is a big deal. Lots of people waiting in line. I hope everyone's bundled up appropriately. It's a little bit cold in this area today. So yeah, and then because we work at a school and our school is a voting place, our parking lot was full of cars coming and going all day today. So, and I noticed the same little chalk marks we used for kids to stand 6 feet apart last week for picture day are all the same chalk marks that people were using today to vote. So,
how convenient.
Yeah, I think we're all used to just looking at the ground and finding that mark to stand on these days. All right, well, typically, either the math teacher runs the science teacher through a bunch of crazy things or vice versa. And so today it's my turn. And so
I'm afraid.
Yeah. And so I am going to walk Ms. Himango through our crazy number tricks that we're going to do today. And we're going to work off the whiteboard quite a bit. And then at the end, we're just going to grab paper and pencil, and we're going to use these number tricks and turn them into a birthday card. So there you go. Okay. If you have a calculator at home, you can play along. So here we go. So we're going to do something called pick a number tricks, and then we're going to end with a birthday card. Here we go. All right. So trick number 1, and at the top it says grab a calculator. And I do believe that this slideshow is posted also, so if you wanted to look at these slides later, you could. Okay. So you are going to, do you have your pen tool? Yeah? Okay, we're both going to pick a trial, so we're both going to work on this board.
Okay.
Okay, and so you're going to pick a number, and this pick a number, add your number to itself. These instructions you're going to follow here in trial number 1, so you're going to fill them in as you go.
Okay. Outstanding.
So you're going to pick any old number and put it in the first box.
Okay, I'm going to bring my calculator with me.
Okay, just in case you need it. And I will socially distance while you do that.
So we'll do 44. That's my age.
And I'm going to pick 5 for mine. Oh, will it let me? Nope. Okay.
Here, maybe I need to be the writer.
Ha-ha. Okay, so we're both going to go, and then I'm going to leave mine for later, and you're going to do your whole run right now.
Okay, add your number to itself. I can do this in my head.
Okay.
88, right?
Yep.
Add 20.
Okay.
108, check my math. I've been working
good
all
so
day.
Far.
Not my best handwriting.
Yep.
Divide by 2. Ooh. 54. And subtract 10. 44.
Oh, did you get your number back?
I got my number back.
Now maybe that's just a fluke, and maybe it's just pure luck that you got your number back. So I'm going to pick my number now, and this particular trick then, what it does is it gives you your own number back no matter what. So let's try it again. Later on, by the way, we're going to come back to this slide, and we're going to do the algebra, and we're going to talk about why. So I picked 5. So now I'm going to add my number to itself. So I'm going to get 10. Then I'm going to add 20. So I'm going to get 30. Then I'm going to divide by 2, which is 15. Oh, if it'll let me. There we go. I'm going to subtract 10. And I have my number back. We could pick anything. We could pick a fraction. We could pick a negative number, anything. This will always work. And we're going to take this Y column and we're going to save it for later. And right now we're just going to run a few more number tricks. In the meantime, if you start looking at the math that we just did, so notice there was an adding your number to itself and there was a subtracting piece. So notice there's adding and subtracting. Okay. When we add a number to itself, we doubled. And you'll notice at a later time we divided by 2. You can start seeing the bones of these tricks and why they work. All right, we're going to try another one. Here we go. All right, they always start the same way. Pick a number. All right, so you can go first, and we're going to...
Can I pick the same number?
Sure.
Is that going to make it hard? I'm seeing a lot of 3s, numbers that are divisible by 3, which makes me think it might be easier math for me if I picked a number that was also divisible by 3s.
Oh, okay.
True?
You can give it a go and see what happens.
No answers here, you guys.
Not
this is
yet.
just a hypothesis.
Yeah.
Let me see. Come on.
And I'll step away from the board. I think the static is getting
12.
Okay, so we got a 12. What are you going to do next?
Add 3.
Okay.
15.
Yep.
Triple the total. 45.
Okay.
Subtract 9. 34.
I think that's subtracting 11.
Oh, 36. I'll erase because I'm tidy like that.
Okay.
Thanks for the math check. So what am I doing? Subtracting 9. So 36.
There we go.
And divide by 3. Bam, 12.
Oh, did you get your number back?
I got my number back.
Oh, so the number you started with is the number you ended with. Nice. All right, so if we're feeling bold, we can pick something a little bit crazier on this. So for example, what if I pick -4? So it says pick any number. I can pick whatever the heck I want, right?
Right.
So let's see what happens. -4 plus 3 is -1. And this is where you can get especially crazy if you just grab a calculator and let it take care of the arithmetic part. Like there's no reason. So a science teacher and a math teacher are going to do a lot of mental math. The idea is to have fun with these, and the calculator is perfectly fine if you want that to get the arithmetic part done. All right, what are we going to do next? Triple the total. So -3. Okay, we're going to subtract 9. So -3 take away 9 is -12. And then we're going to divide by 3. -12 divided by 3 is -4. So even if we pick a negative number, we still get our number back. Did it matter if we picked a number that was compatible to all those 3s in this case?
No.
Because -4 is not particularly compatible with 3, multiplying or subtracting or whatever. Okay. So there's the second one. So, but we do have some patterns here. We do have adding 3s, we do have tripling, we do have dividing by 3s, we do have subtracting 9. So there is some sort of thing going on with the 3s in this math puzzle. And we're going to stop and sort that out in a little while.
Okay, I'm taking notes.
Okay, got it. Yeah. All right, we have a few more of these to try.
Okay.
All right.
Any number.
Pick any number. Okay, let's see what she does this time.
I want to do a fraction.
Do you want to start with that as your first trial or your second trial?
Oh, I'm doing 2 trials?
You can do 2 trials if you want to do.
Okay.
Yeah.
Well, maybe I'll pick an easier number than a fraction, although I do love fractions. How about, let's see, 11.
Okay. Here we go.
Add 3. I'd get 14.
Okay.
Multiply the sum by 10. I get 140.
Sure, you got that 0 on the end as a placeholder. Nice.
Subtract 30. 110.
Good.
Divide by 10. Back to 11.
Oh, you got your original number back.
Yes.
Ah, okay, got it. Okay, and this time we have something about adding and multiplying by 3 and subtracting 30 and 10. So this one seems to have 3s and 30s and 10s in it. Now, if you want to, you can grab a fraction and give it a go and see what happens.
Okay, will you help me with the math as we
Sure,
go?
you bet. And as a matter of fact, I'm going to grab my calculator just to make sure. Pick a fraction that I can calculator. How's that?
Okay, I will pick 1/2 because that's a pretty
There we go.
easy fraction.
It's kind of the uber fraction, huh?
Yes.
And I can type it in as 0.5.
Add 3.
Okay.
3 and 1/2.
Yes.
I learned that from baking, y'all.
Heck yeah. Okay.
Multiply the sum by 10. So now in my mind, can I convert it to a decimal?
It's a great idea.
Okay, so that's 3.5 times 10 would be 35.
Yep, absolutely.
And then subtract 30.
Okay.
So I'm back to 5.
Uh-huh.
And I'm trying to look for patterns too on the numbers in each of our trials, but it's not totally obvious to me what those might be.
Uh-huh. That's what the algebra is going to be for later.
Divide by 10. I will even show my work, Miss Baker.
I am very excited about your work. 5 divided by 10 simplifies.
Is 1/2.
So that fraction worked.
Yeah, and that wasn't too hard.
No. And so starting with things where you're pushing the envelope a little bit, like with a negative number or with a fraction, but not picking something super crazy, although anything will work. We could have put in pi here. We could have put in 3.14195, blah, 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 forever, and it still would work. Okay.
Interesting.
Yeah, so now the question is again, are we seeing some patterns? I think we have 4 or 5 of these tricks today. And then from there, we're going to go back and take them apart, and then we're going to build our own.
Okay, I'm trying to write down the formula so that I can notice the pattern.
Okay.
Maybe.
Yep. All right, here's trick number 4.
Okay, pick any number.
Uh-huh.
Now we're doing 7s, 5s, 35, 5.
Yep, so that one, the bones show a little bit better on this one maybe, huh?
Okay, let's do 1/4. I'm feeling brave.
Okay, here we go.
1/4. Add 7 is 7 and a 4th.
Okay.
Multiply by 5.
36 and a quarter.
Whoa, you're fast.
7 times 5 is 35, and then a 4th 5 times is 1 and a 4th.
I know you didn't even give me a chance.
Okay, I'm so sorry. I got excited and I blurted. And you know what we say in math class? Blurters are hurters. I'm so sorry.
Okay. Subtract 35. We get 1 and a quarter.
I'm controlling myself.
And divide by 5. Well, now I'm guessing it's going to be 1/4. But we could check the math.
And we can, if we
5
look at
4ths.
Yeah, so if we look at
5.
1 and 1/4, so 1 is, if it'll let me do it, 1/4 and 1/4 and 1/4 and 1/4. That's 1 and a 4th. So if we divide that by 5, we can see that it's going to be a 4th.
Oh, that's a nice way to do that.
This is called decomposing, which always makes me laugh because we decompose numbers.
Yeah, I love it.
Yeah. Okay, got it.
A word
so
that
even
has
if you pick
multiple
something
meanings.
messy, so let's try another negative. Let's go negative 10. Let's try that.
Okay.
Oops, that's a 10. Well, okay, it's a 10 with a comb over, but it's still a 10. All right, so we're going to add 7. So it's going to be negative 3. Okay, we're going to multiply by 5, so we're going to get negative 15. Okay, I'm cuddling my calculator to my chest like I'm going to need it in a minute. I think I'm okay. Let's see, we're going to divide by 5. So
Calculator love. Negative 3.
I forgot where I was. Wait, multiply the sum by 5. Yes, did I subtract 35 yet?
I don't think so.
No, okay, so I'm going to get what, negative 50? Like that. And then divide by 5, I'm going to get negative 10. Dun, 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 dun. I wish I drew on this board a little bit better. My writing is scandalous. Okay. So did I get my number back?
Yes.
Okay. Now, we're going to go back and figure out the y. Okay. And then when we're done, I have a like a worksheet for us to do, and we're going to come back and notice we're going to start this one when we come back is we're going to start at the bottom and work our way back up. So we're going to decide what we want to get, and we're going to go from there. All right, so now we're going to go back, and we're going to algebra the heck out of these. By the way, sometimes we stop and tell a joke or two. Do you need a math joke right now?
A student told me a dog joke today.
Oh, let's have that. We'll start with the dog joke, and then I'm going to tell a math joke. Okay.
And what do you call a cold dog?
A cold dog, not a hot dog. I don't know.
A chili dog.
A chili dog. Oh, it was food related. Oh, and I missed it. Okay. I have a joke that I tell once a week to my classes all year long, and they just have to put up with it. It's my favorite math joke ever. What did one math book say to the other math book?
You have a lot of problems?
Yeah, I got a lot of problems. Yeah. Okay, do you know why the math teacher did giant paint on the side of his house 2 + 3 = 5?
No.
It was the only way he could afford an addition.
Ah.
All right.
I got to remember those. I'll write those down too.
Oh, yeah. Well, let's do a little bit of algebra, and then I'll tell you another joke. How's
Okay, that sounds amazing.
Got it. All right. So now what we're going to do is we're going to talk about the algebra of what the heck just happened here.
Okay.
Okay. So I'm going to kind of walk you through the first one. So pick any number in algebra typically is a variable.
Okay, I want to call it X.
Okay, so we'll call it X. We don't have to, but it is very traditional. All right.
I'm a creature of habit.
Add your number to itself.
2X.
So we've got options. We can either add the number to itself, like that, or we can take a shortcut and we can call it 2X, which I'll just put in the margin. Okay. Then we're going to add 20.
Okay, so X plus 20.
So we're going to have 2X plus 20. Okay, so that's what we have so far. Then we're going to divide by 2.
2X plus 20 over 2.
Uh-huh, and so just cut them all in half. So what's half of 2X? You can probably
X
see it half
plus
better here.
10.
Uh-huh, so you're going to get X, and then half of 20 is 10. And we literally just have half of these 2X's and half of the 20. Good, and then what was the last thing we did?
Subtracted 10.
And we're right back where we started. So it doesn't matter what you pick. You will for sure get your number back in this case.
Interesting.
Yeah, isn't that fun?
Yeah.
Yeah,
I
now
like
we are
it.
going to tweak it in a minute, because in a minute what we're going to do is we're going to play a game where no matter what you pick, we get a 12.
Okay.
So we are going to do a different thing when we start our birthday card. Okay.
This is math teacher parlor tricks.
Yes. And so now we're going to see if you can algebra your way through one. So see if you can come over here and see algebra it until you feel like you're stuck, and then I'll give you a nudge if you need it.
So I'm going to start with X and add 3. So X plus 3.
If the board will let you. I think you can't have your knuckles
You know
close
what?
to it.
I think it's the dirt off the table on my fingers.
Oh.
Okay, X plus 3, triple the total. So it's 3. I'll try a different finger that's not dusty. X plus 3.
Okay.
Is that correct?
Uh-huh.
Okay,
Yeah.
subtract 9.
Okay, and now we might need to write this in another form. So what's the other form?
Combine everything.
Okay, good.
Or distribute, is that what it's
Yes.
called in math terms? 3x plus 9
Uh-huh.
minus 9.
Good. Yeah.
Divide by 3.
Uh-huh.
So this whole thing would go over 3.
Yes.
Would leave me, because these go to 0.
Yep.
So
And the 3's cancel.
are we allowed to say cancel these
Well,
days?
no, we say it divides out, but anyway.
I still say cancel, and
And it
I've
comes
gotten
out to
scolded
X.
by a different math teacher.
Oh, yes. Cancel is very old. Yeah. Because like on TV, if you cancel something, it goes away. And here, we're actually dividing it to 1.
Semantics.
So yes, if we're going to speak in a way that makes more sense. All right, look at you algebra that.
So it's called not canceling, but what? So I get
So
this
if
right?
we have 3x divided by 3, the old language is canceling, but really what we're saying is 3/3 is equal to 1, if it will do it for me. And so really what we're saying is divide out the ones,
Okay.
is what we're saying. And then when we divide out the ones, we have 1x over
That's
1.
so many words
It
to
is.
say one thing.
Yes. And the problem is that cancel is misleading. Okay. So cancel implies that something went away, and it didn't go away, it just changed form. So in any case, all right, here we go. Do you think you can algebra one?
Yes, I'm going to
Okay.
get crazy and use a Y and dust off my hands.
All right.
Okay.
And I'm just going to try and give you a little space while you work. I'll just go over here.
Sounds good.
Okay, we'll just trade the
Oh,
spots.
there it goes.
Okay.
Wait, try again. Nope, wrong finger.
Okay.
Okay, so I'm going to add 3, Y. I'm not renowned for my outstanding handwriting. Plus 3. Multiply the sum by 10, so 10 times Y plus 3.
And then see if you can get that expression on that same line. So keep going, like put an equal sign and see if it'll let you keep going.
10y. Y.
Oh, it's not going to let you go.
I think one finger gets fatigued.
Okay.
Plus 30.
There we go. And so that's the expression that you want to think about for the next part.
Okay, divide by subtract 30. Well, that sure is easy.
Oh, it's easy, she says. Look at her go.
I was worried. Minus 30.
And you can cross those guys off.
Do they cancel?
They add to 0, but anyway, yes.
Divide by 10. Leaves me with y by itself.
Dun, 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 dun. So it does not matter what you pick. You will get your number back. The other thing that's kind of fun about these is when someone makes a math error and they say, no, it doesn't, no, it doesn't, and then the whole class attacks that particular problem to see if they can make it work. We try to attack the math, not the person, so that is important. But sometimes you try one of these, and the algebra says that it's ironclad. You cannot pick a number that will break this problem. But you can accidentally type a number wrong in on your calculator or just do funky arithmetic that doesn't work. So typically, if you put in a number and you don't get your number back, and you've already made it work on a couple other trials, what you know for sure is that just you have to go dig out an arithmetic error somewhere that happened. All right, I think we have one more. And then we're going to build one.
Trick 4.
Okay.
I'll use n this time.
Okay. And I have a theory about the board. I think if the rest of your hand is too close to the glass, it doesn't go. I think you have to like use it like a pen.
Okay.
That's my theory.
Interesting theory.
Yeah.
I'll try it. It's an experiment. Oh, it's working. N plus 7.
I think there's a sensor in the frame is what it is.
Oh.
Yeah.
Multiply the sum by 5. So I know I have to take this step.
Okay.
So I know what's coming
She
next.
shows all of her work.
True.
Yeah.
So we have 5n plus 35.
Yeah.
Because I multiplied this.
Yep.
Then I multiplied that.
Distributive property. Well done.
Thank you.
Very nice.
And now I subtract 35. So that last step is, I'm noticing, quite easy.
Yeah.
Who figured these out, by the way?
I don't know. They've been around in math books for a long time, and they're amazing with algebra tiles. I didn't do algebra tiles for this one because 35 little tiny algebra tiles would make it really tough. But you can really demonstrate these with the algebra tiles too. Look at that. Nice. All right. So now we can invent one. And we're going to switch it up a little bit because we're going to invent one that always comes out to the number 12. So we're hoping that there are some 12-year-olds out there, and we're going to make a number trick that always comes out to the answer 12 no matter what. Because as you know, most 12-year-olds are the center of the universe, or should be, right? If you're 12, you know this, don't you? All right. If you're 13, I'm sorry, you're a little bit past it.
They don't know that yet.
No, they do not. Okay. So the way we do these is we're going to start by adding to 12. And our next step is we're going to go 12 plus x right here. Oh, wait, I got to erase. I don't like what I just did. Wait, do I have a back button? There we go. Okay, we're going to try again. Back to the pen. Okay, so here I'm going to go 12, if I can, plus x. Okay, and now we're just going to decide what the heck we're doing. So maybe we'll double everything. Okay, so if I double it all, I'll get 24 plus 2x right there. Okay, and let's see here. What would I like to do next? Oh, maybe right here I'll say add 24. So maybe here I've got like a 2x, and here I can start with an x, something like that.
Okay.
So I'm just kind of playing with it to see what I can get. So these instructions would be pick a number, double it, add 24, cut it in half, and subtract your original number. That's the only thing we're going to change here.
Okay.
To get our instructions. Okay. So here we're going to say pick a number. Ooh, this is the hard part. Pick a number, double it. So here's my doubled number. I'm going to add 24. Like that. Okay. So there's there. I'm going to cut the total in half. Oh, it's a mess. And now here's the only tricky part. You have to subtract your original number instead of subtracting 12.
Okay.
So then we're going to subtract original. Oh, it's a mess. Number. Okay, so let's give it a try and see if it works. Let's see if we get a 12 every time.
Okay.
Can our first trial be something simple so we can see it work?
2.
Okay, let's pick a 2.
Okay.
Let's try it.
So.
Okay.
So move my hand to more weight. 2.
Okay, wonderful.
Double it.
Okay.
4.
Good.
Add 24. 28.
Good.
Half. 16.
Half is 14. You're trying to trick me. And subtract your original number.
12.
Oh, look at that. So no matter what we pick, we'll get a 12, no matter what.
Okay.
Okay, so now let's pick something crazy.
Very weird.
Okay, we may not have time to build our birthday card today, but you can see where you could put this in a birthday card and say, hey, here's your thing. So you pick a number, double it, add 24, cut it in half, subtract your original number, and you'll get 12 no matter what. Let's try something crazy. How about 100?
Okay.
I think we all like 100.
Now I have to be a little more on my math game.
Okay, double it.
200.
Okay, add 24.
224.
Good, half.
They're
They're all even digits.
1,
Pretty
1,
nice.
2.
Okay, subtract your original number.
Was 100.
I
end up at 12.
Oh, bam, baby, look at that. So at the very end, the only thing we changed in this compared to all the other ones is the last instruction, instead of subtracting a certain number, was to subtract your original number. And you can see if we take out the X, we ended at 12 every single time.
Interesting.
Like that. Yeah. So then the fun part is that you can actually make little birthday cards, and in the birthday cards you can put in these instructions. Pick any number, double it, add 24, cut it in half, subtract your original number, and you get 12 no matter what. So I thought today we would maybe use this. And then at school, I bet you we know someone who's turning 12, and we could take our birthday cards to school and find someone, and we could actually send them a birthday card that has.
So where do you like to write the instructions? On the inside?
I do.
Okay.
Yep. So I wrote, happy birthday, now you're 12, on the outside of my card. And now I'm going to put the instructions in there. And of course, we didn't have to do, you could play with this. You could put in more steps. Once you get the hang of this idea and you get the variable piece down, you can go nuts with it, huh?
If my nieces are watching, forget this part.
Oh yeah.
If you get a birthday card like this, don't be surprised.
If you're turning 12 in the next 3 weeks, go like this, do not listen.
Yeah.
Okay, because we're making you a birthday card right now. Okay, so pick any number, double it.
Okay.
Okay, add 24. And sometimes you have to say add 24 to the total, Okay, all right.
So thanks for watching.
Yes.
And join us on Thursday. We're actually going to make Newton's discs. So it's like a homemade fidget spinner, reverse rainbow, which I don't think I have time to get it going right now, but we'll try.